All right, well, good morning, and welcome to Management in the Data Center, or SIM 208, according to your program guides. If you are not here for Management in the Data Center, you want to go talk about Windows phones, or you want to go talk about dev tools, now's a good time to step out. This plane is going to manage the data center. My name is Ryan O'Hara. I work in Redmond looking after product management for our System Center infrastructure tools. And that's going to be a lot of what I talk about today, how System Center and the underlying hypervisor, Hyper-V, is working to build out private clouds, data center infrastructure that is simple to use, that is built with an eye towards your applications and service levels, and brings the automation and process maturity that you all need to run a robust set of services. I'm going to be joined on stage by a number of crack demoers and presenters here in the front row. These guys have been traveling around the world since our Microsoft Management Conference and now our Tech Ed. And they've come back from Istanbul and South Africa. I'm very happy to have them all here, and I'm sure they'll make for some enjoyable demos. So we're just going to jump right in. We'll be a mix of slides and demonstration here in about half and half. And make sure we get you out of here on time. Before I start, how many of you were in the keynote session this morning? All right. So it looks like everybody. I can assume that you saw Joey Snow early on doing a demonstration of a product called Concero, System Center Concero. And that was about managing services, complex services across private and public clouds. How many of you were at Norm Judah's public and private cloud session, the foundation session? Norm is our CTO of services. Only a couple of you. OK. In that session, Norm had a demonstration where we built a converged infrastructure, carved it up into some data center elements. And I'll be talking about some of those demonstrations today. But I'll make sure I talk through them thoroughly so that you all have the context. So we'll dig into the slides then and kick this thing off. And I'll start on this slide because quite often by this point in the day, we're 3 sessions in now, basically. And you've probably heard cloud about, 267 times. And I'm going to say cloud throughout my presentation as well. My use of cloud, I hope, is going to be grounded in the technologies and some of the consoles and the experiences that you know from your day-to-day jobs, from a data center administration standpoint, and hopefully from a familiar System Center console and tool perspective. When I talk to people about cloud computing, I tend to get naysayers that fall into one of 2 camps, people that just don't want to hear any more about it. And the first is kind of represented by this top arrow on the slide. It's the folks that would say, look, cloud has been hijacked by marketers, and there's no technical merit to the conversations that I have about cloud. What cloud means to me is somebody in my management chain showing up with Information Week and saying, look, we need to have a cloud. That's sweeter than a Georgia peach. And then the other camp says, look, I know that cloud is maybe all too real. Cloud is actually this kind of threat to me and to my organization. Cloud, especially the public cloud, is something that I see business unit by business unit going around IT to consume critical services. I see them going to Amazon. I see them going to even Windows Azure. And what's happening is there's this leakage of critical applications, critical infrastructure outside of my purview. And so cloud, I don't want to talk about cloud because I don't want any more of that stuff. I think there's a third camp. I think there's a third camp that says that cloud is very real. It's not a location as much as it's a type or a style of computing. I believe that cloud stands for a set of benefits related to the agility or the time to value that IT can have in response to the business. I think it stands for an economic model of taking standardized or commodity resources and assembling them into a powerful infrastructure for running line of business applications. And it stands for an improvement on the service levels that we promise to our organizations and we hope to deliver through the men and women that work on our teams, as well as the tool sets we depend on and the resources that underlie all of those applications. And that's where I want to spend our time, talking about cloud as a real thing, and talk about how Microsoft's promise and commitment to you is to simplify the process of building out this cloud-style infrastructure, that we can help to automate some of the running and servicing of that infrastructure, and that we can make that sing in accordance with your critical applications. Now, the reason that would be a good thing is because all the benefits of cloud, well, they're promising things that we've been wanting for a while. You know, we look at the 5 stripes or the 4 stripes up here, and they're basically the unicorns of IT. We're going to be able to give self-service experiences to everyone in our organization. Those services are going to be derived from shared resources that we can carve up for individuals as they come to us looking for their slice of the pie. They're going to be scalable. Scale up, scale out. Don't worry about it. Never going to fail. And then we can do this all in a pay-for-what-you-use model. Well, you know, you've been asking Microsoft and other vendors for that since we started. So if cloud computing can get at that, well, then that'd be a worthwhile conversation. And I believe that some of this style of computing, this cloud computing style, can take us steps towards some of these elusive goals. From a Microsoft perspective, we're going to invest in all sorts of cloud computing scenarios. Whether it's machine-based infrastructure as a service, we're going to provide that. Whether that's in your data center or that's in our data center, we're going to be there. From a platform as a service perspective, we're going to make sure that the platforms that you rely upon, .NET, for writing your business applications, extend to this compute model. And then for those of you that want to just transform the way business productivity is consumed, we're going to SaaSify things as well with offerings like Office 365, where you're seeing our SharePoint and our Exchange servers online. But we're going to invest in all of it so that you can consume whatever portion of it you want. This isn't a take-it-all sort of proposition. This is something that is transforming everything we do in our jobs at Microsoft so that you can integrate whatever portions of the cloud computing transformation you would like. Now, one of the places where we've invested significantly over the last 20 years or so is in our data center footprint around the world, our global delivery capacity. And what this map represents is actually the data centers, or the capital data centers, if you will, of our global infrastructure. And of course, in addition to the named ones up here, we have a whole bunch of regional data centers that aid in the delivery of capacity around the world. This is important because since the time we built our first data center in 1990 or so, we now deliver over 200 global services out of our data centers, whether that be Hotmail, whether that be Azure, our Office 365 services, or consumer services like, like Xbox Live. We are building and providing these services from this data center footprint. And this is wholly owned stuff. From the fiber to the facilities to the compute network storage devices within the facilities themselves, this is our stuff. We talk about this data center footprint being more than 10 and less than 100 facilities. To give you kind of a range there. We never really quote the full number. And there are some hallmark data centers in this footprint here. There's a couple of really cutting-edge data centers, like the one in Chicago, where we have basically standardized on shipping container format for provisioning about 2,000 servers at a time into the running service infrastructure. Or the Dublin data center, where the Dublin data center is about I think it's a 350,000 square foot facility. We built out the first half with chillers on the roof. We looked around, noticed the ambient air was something like 60 degrees on average. And we talked to the chipset vendors, and we decided we probably didn't need chillers. We could actually go ahead and cool the facility just with ambient air. So we never installed the chillers on the second half of the facility. And we use open air vents to bring in Irish sea air and use the natural resource around to do all of our cooling. And over in Quincy, Washington, we've got our million square foot facility sitting next to a hydroelectric dam, and all of that power that we consume is hydro. And so there's a bunch of experiments that we're doing with the industry here as we build out this infrastructure. And what we do is we collaborate with our OEM partners, with our network vendors, with our storage vendors, to bring this grand experiment first to these data centers, prove it out, and then share these capabilities going forward. Well, the reason this is important in the context of our discussion, in the context of your data center, is because we get to have all of these learnings in these public data center facilities and bring them back to you by way of our on-premises products. So as we deliver the Azure service, we can bring some of those learnings back to Windows Server and back to System Center. Now, as we do that, as we take a walk inside one of these data centers, there's a couple of hallmark characteristics that it's important that we talk about. The first characteristic when you walk inside one of these data centers is you find extreme standardization. Absolutely extreme standardization. While the data center is ultimately divided into a set of colo facilities by each particular app, within each room, we have standardized and stamped out rack upon rack upon rack of 100% uniform hardware. Standardized the networking equipment, load balancers, storage, etc. The other thing that we've done is we've carved up all of this uniformity into very business-specific environments. And what that means is that the Office 365 applications get their spec'd environment. The Azure team gets their spec'd environment. And so the reason this is important is because we have this partitioning between the business units. What the Azure team needs doesn't override the needs of the Office 365 team. They get to maintain their specific footprint as their applications require. And this segregation or this partitioning is important as we get into the private cloud or the private data center as well. The next thing that we see in these data centers is the applications. The applications are built in a manner that behave, they're sort of good citizens of the data center. Generally stateless applications that are transient across this fabric of compute infrastructure. They don't marry themselves to any operating system instance. And this is important because they were built in a way that assumes that things are going to fail. If you assume that things will fail, drives will fail, operating systems will drift and need to be remediated, well, the architecture of the application becomes very important. It has to be resistant in the face of failure. And what these applications do is they reserve any of their state from any underlying resource, turning it truly into commodity. So that if we have to go in and troubleshoot a machine, we can just move the application workload onto another clean machine and troubleshoot that particular instance. The next thing that we see is process maturity in the form of a couple of different areas. One is very unique and reimagined processes. What we didn't do is just take a bunch of runbook automation and slam it on top of historical processes. What we did is we asked ourselves, what are the right processes, what are the right approaches that we might take to normal maintenance? An example I typically give here is troubleshooting drive failures on a rack. So if we have a particular drive go wobbly in one of our racks in, let's say, the Bing room, we don't send out a tech. We only cut a ticket after maybe 10% of the drives in the entire rack start to fail. Because it doesn't make a lot of sense to go send out a tech for that, for just that one drive. We go out really because now we just have to do an entire refresh of drives with our OEM providers. We've thought about the process a little bit differently. And it's not really important that we preserve that drive because there's really nothing of value on it because the application hasn't installed a whole bunch of debris onto that operating system image. So we could rethink that process. So now what we do is we send out a tech after 10% of the drives fail. They rip them out of the machine. They walk over to a shredder. They dump them. And then we place an order with one of our OEM vendors. The other piece is that we've automated the heck out of the place. There are very few human tasks that we actually take. We aspire to make it almost entirely remotely operated. And you walk into these facilities, you know this because there are only a couple of people that service the facility. The facility manager and about a team of about 6 full-time individuals, and then a number of just vendors that are on site servicing their different elements. And we do this through robust use of runbook automation. And we marry that with draconian change control. You don't get into this facility until a ticket is cut. You don't go and change any environment. Even having a meeting in these facilities requires a ticket. And when the ticket expires, they come and ask you to exit the building and end your meeting regardless. It's that sort of spirit, that sort of philosophy around good process maturity that is critical to maintaining a well-run, standardized data center. And as a result of all of this, they have a predictable set of operations that are tightly controlled from a data center administrator's perspective that then they can offer out through self-service. They can have the audacity to put up a portal for the world to come to and say, I want an Azure container. Please provision one for me in the next few minutes. And all of that can happen after swiping a credit card. That kind of self-service interaction with this kind of data center infrastructure is really transformational. There's something to this cloud computing thing. So what I want to talk about is not so much how to go and do it in these data centers, but how do we get the spirit of these learnings into your data centers? How do we actually take the attributes that we experience and put them into our private cloud stack of Hyper-V and System Center so that you can get some of these benefits in your organizations? So when we think about the private cloud, it really starts with these two ingredients. Hyper-V on the left, and System Center over there on the right. And before we can get into the process management and the automation and the application centricity, we have to start over on that left-hand side with a rock-solid foundation. In fact, we've been challenged by you to say, show me that you're enterprise ready. Show me that you're ready to be part of my mission-critical infrastructure. The underpinning that serves as the foundation for all of my applications virtualized upon Hyper-V. So we looked in our own backyard first and said, let's make sure that we can be best in class at virtualizing and running Microsoft applications that businesses rely upon today. And we went out and we asked third parties to benchmark us, to look at Hyper-V. And look at some of the characteristics that came back. From a SharePoint instance, we had a single server hosting over 460,000 lightweight users on the SharePoint server. Similarly, a SQL server simulating over 80,000 OLTP transactions. And an Exchange server running 20,000 Exchange mailboxes. We looked at these benchmarks relative to any other vendor's benchmarks of Hyper-V or virtualized application instances of these types meaning our stuff virtualized on even VMware infrastructure. There are no greater, no larger benchmarks than the ones that I'm showing you here. We believe that we can give you an industry-leading experience on Hyper-V. And that's absolutely critical because that's the foundation upon which we go and build. Now, the response to this sort of proof has been significant around our ecosystem. And as we do this, we start to get more and more encouragement of Hyper-V being the foundation not just for Windows guest experiences, but also Linux and Unix experiences. And Hyper-V has been developed as a cross-platform hypervisor in terms of hosting multiple platforms in the guest environments from the get-go. But one of the things we get to announce today is that we're expanding guest support in Hyper-V to include CentOS, and continuing our movement to bring more and more of the workloads and the guest environments that you look to onto this shared infrastructure. And this is particularly, feedback that we get from our hosting community as well, who relies on CentOS quite a bit for their Linux distribution. Now, the second thing that we see is our channel providers coming around and rallying around Hyper-V as well. Vendors like IBM, vendors like Dell and HP, vendors like NEC and Fujitsu have worked with us to develop these fast-track architectures for deploying Hyper-V on a converged infrastructure environment from each of these OEMs. And adding to these configurations, I'm also announcing today that we have reached an agreement with NetApp to provide a converged infrastructure solution that is the NetApp Hyper-V Fast Track with Cisco as the OEM provider for this server infrastructure. So continuing to expand all of the opportunities around business-critical application experiences, expanding the guest environments that are coming on top of Hyper-V, as well as the different infrastructure partners that surround our software and deliver a great experience in your environment. But what's most important and what we care about most is our customers getting their hands on the software and experiencing it and running real experiences on top of our software. And I want to share with you a quick video of a household name, Target, who is building upon Hyper-V as the foundation for their store experience and really the basis for how individuals interact with their brand. So I'm going to roll a video and we'll come back to the chat.
Target differentiates itself based on having a high-quality guest shopping experience inside of our stores. That depends on having product on the shelves and a speedy checkout. The business applications that enable those processes for our guests run on Microsoft Hyper-V.
With over 1,750 stores and no IT personnel in our stores whatsoever, it becomes really important to be able to manage these environments remotely. One of the mission-critical applications that we virtualize in our stores is Microsoft SQL Server, and it's imperative to being able to operate a store. It helps our team members receive merchandise from the trailers, put it on the shelves, and stock it in the back rooms. Microsoft and Dell helped Target develop a model that we would use over the next 5 years to determine what our growth looked like. We leveraged the Dell R710s in our stores because they provided us a hardware platform that we could grow into. We're doing over 1,000 stores this year. We're going to finish up the stores next year, where we'll have over 1,700 stores, over 3,600 hosts running Hyper-V, with over 15,000 virtual machines.
If you think about our requirements as a retailer, it's really important for us to have total confidence that we can process transactions during the fourth quarter, during our holiday season, when transaction volumes go way, way up. And we found that Microsoft Hyper-V met all of our requirements and had no problem keeping up with the transaction volumes that we needed.
So a quick case study of how Target is implementing Hyper-V, and I can tell you, having spent time with Brad and Fritz in the video, those are two tough customers who have really demanded that we deliver on the promises and the potential that is available through virtualization and cloud computing. Now, I want to get into System Center a little bit, because I'm a management guy and this is where I spend most of my time. And I hope that you do as well. From a System Center perspective, we're about to launch System Center 2012. And when we bring System Center 2012 onto this enterprise foundation of Hyper-V, we're going to deliver on the promises I was talking about earlier in the presentation. Let's talk about how we're going to do that. The first thing is that in stark contrast to the enterprise or the global data centers that I was referring to in our facilities, most of you probably have something that has a little bit more diversity in terms of its infrastructure. The compute infrastructure is a little bit different. The storage arrays, maybe SAN, maybe DAS, like maybe a little bit of both. Not really normalized network infrastructure, et cetera. But that's okay, because we have an opportunity to unify the infrastructure assets that are available in your environment into a logical layer, providing some abstractions at the network level, providing some abstractions at the machine level, and at the storage level as well. And we do this through Virtual Machine Manager, creating a logical infrastructure of pooled resource. Now, the important thing is that we've done is we've taken a look at this and said, well, if we're going to embrace the infrastructure that's there, both software as well as physical infrastructure, we need to embrace vendors like Zen Server. We need to embrace vendors like VMware and ESX in the environment so that we can create a fabric of infrastructure, a uniform slab of infrastructure from which we can power the rest of your organization and the rest of your applications. And so you'll see in Virtual Machine Manager 2012, we provide that support, not only for network storage and compute, but across many vendor types as well. The second thing then that we want to do, having established this slab of infrastructure, this pool of resources, we want to give you the ability to carve this up into logical partitions. So you can think about these as virtual data centers or logical data center partitions. And in the slides, I've got an example where we've carved them up for different functions within the organization. But this could also be for different business units, for different geographies, for a school system that has many branches, a local government. And in Virtual Machine Manager, we call these clouds. And once we carve out and establish a cloud, we can then start to provision the users that have access to the clouds. We can determine what are the library of resources that are available to those users, whether they be machine templates, whether they be VHDs, and the building blocks within which that they get to go and build and deploy things. The other thing that we can do is we can start to put some guardrails on individuals or even groups that participate in these clouds. So I can say that Ken and Owens, my demoer, can only deploy 10 virtual machines as a maximum, so that he doesn't go and steal all of the capacity that's available in one of these logical footprints for himself. And we're providing simple interfaces to do this in Virtual Machine Manager. And anyone who saw the foundation session with Norm Judah would have seen Kenan, in fact, implement one of these clouds and go through some of this partitioning. Now, in System Center 2012, we thought that we should go beyond this, though. The industry's kind of here. We've been having a discussion about how to pool resources and create logical data centers as an industry now for over the last year. But the end goal isn't really about a logical data center. The end goal is about the applications and services that are going to run within these data centers, within these clouds. And so we took a next step with System Center 2012 and really doubled down on application management in terms of the provisioning of complex services and the mechanisms for maintaining those services over their life cycle. And so we introduced this concept in Virtual Machine Manager around the service template. And you're going to see all of this in just a minute, but the service template gives you a standardized recipe, if you will, for how one might provision or build an application. Think about this today. You get a clean environment, you finally have the access that you need, and it's time to start building out a particular service. Let's say it's a 3-tier application. The knowledge around that provisioning experience, that build experience, is probably in somebody's head, maybe in a Word document, and at best in a runbook. What we thought we could do is we could help to capture the definition of this service. First of all, what are the different components that make up this running service? And then we could start to capture information about those components. Which ones should be deployed first? If we're going to deploy this N-tier application, maybe the data tier ought to be deployed before the application logic. Because when we try to go and configure and bind the application tier to the data tier, we're going to have failure otherwise. Well, that's important instruction that we can align to the service template and capture in the tools. And it will aid in the maintenance as well as the provisioning of the service over time. The second thing that we looked at was inside the application or service template itself. We said, how many operating system images do most customers work with? Everyone would aspire to say, hey, I've got a couple of gold standard images. I've got maybe something that I've hardened in terms of web configurations, web-facing configurations. I've got a couple that I like for new application development. And maybe I've got some a 2003 image of Windows for legacy applications in the environment. OK, that sounds great. So we get down to like 3 or 4. But then we start to deploy applications on those, and those applications write to the file system. They write to the registry. And when Patch Tuesday comes along and we need to patch one of these operating systems, we actually have to go test against an exploding array of operating systems, because we don't have 3 gold images. In this example, we've got 3 gold images times however many applications you have customizing them. And we have this test problem that's exploding. It's a combinatorial problem. So what we asked ourselves is, could we help with this a little bit? What if we could separate the applications from the operating system? We have some technology in terms of virtualizing applications that allows us to introduce a virtual shim between the application instance and the operating system. What it does is it sequences the application and watches the application as it tries to write and install itself to that OS, touching file system or registry, and virtualizes all of that and suspends it from the operating system. As a result, we truly get to a clean image, a commodity image of the OS underneath that app. And this really changes the way then we can think about maintaining the operating system over time. As we think about patching the system and the underlying service, we can patch an image of the operating system, but not have to go and retest each running application. And we can simplify some of those standard processes. So to introduce you to this through the tools, I'm going to invite Ken and Owens up to give us a tour of all of this in System Center.
Thanks, Ryan. Thanks, Ryan. So, great. How many times have you, as an IT pro, been asked by an app owner to say, hey, can you build me this nice 3-tier application? With this 3-tier application, I want you to have 3 web servers in the web tier, a couple servers in the app tier, and then maybe a SQL server in the back end. Well, within System Center 2012, or what would it mean for you today? You'd have to build that with all those different virtual machines, create a bunch of different VMs for that. But then not only that, you'd have to build maybe a staging environment and then a couple of dev environments so they can work on the updates for that application. So you have this one set of service, but it means a lot of different deployments for all the different operating systems. Within System Center 2012, we have this view of clouds and services, and a service is a collection of virtual machines. And not only is it a collection of virtual machines, but it builds around them tiers and scales and allows you to manage them one by one on these services to start, stop, restart them as you need at either the tier level or at the whole entire service level. But what is a service made up of? As Ryan said, we have multiple different templates and repositories. And if you look at what a VM is made up of, it's made up of an OS with the application installed on top of it. And when you deploy it, you can marry them together and deploy that. So what that means is that you have your tool, you have your ability to have your virtual hard disk. And these are all the different hard drive OS images that you may be managing. But what you also have is your application package now that you can install on top of this. So I can have less hardware OS images, and I can deploy these applications onto that same OS hardware image and have it happen at deploy time. One of the things we've done is with server application virtualization is allow you to create encapsulated images of the application that you can have versioned, and when you deploy that application, it'll marry it at deploy time. But also, when you create a service, it will allow you to configure how these applications in these different tiers relate to each other. So let me kind of show you what that means. If we look at service templates, I have a bunch of applications here. But let's create a brand new service template. And a service template is the source of truth for a virtual machine. We'll use a blank service template here. We'll call it Ryan's app. And at that point, we'll bring up a designer. And this designer allows me to drag and drop the different components for that service onto the designer window. And he needs a SQL server for this application, as well as a application or a data. Let's give him a data application here. So what he has now is we don't want this one. That's another SQL server. We want the order template here. So I just drag it on there. And at this point now, I have an app tier and a database tier set up for my application. They're connected to a network. And I can choose, do I want this on the production network or maybe on the development network? For each of these servers, I can decide what's installed in them, and by having that template, decide which SQL DAC pack for the SQL server and which application virtualization image for the application. Then I can take that image. I can also do things like, well, this application server is clusterable and can scale out as I need to come under higher workload. So I can choose the ability for have this machine can scale out. It maxes out at 6. I'm going to have a default at 3. So that what happens is it'll deploy 3 of these when I first deploy it, and then it can scale out to 6 as the load changes.
And this is an important point as it's capturing, or we're setting up some guardrails so that, right now we're not scaling the service itself, but we're basically saying these are the parameters within which an operator of this service can scale up or scale in. But they can never go beyond these particular guardrails. So Kenan has control of this particular service.
And once I've created this, then I can just assign it to Ryan, and he can deploy it as many times as he wants. Saves me time, create this one time, but now I can deploy it all those many times. So let me save this and close it and show you an application that we've been tinkering with and we have filled out that kind of shows this in a little more broader light. All right, close that. Also, I have in here, like I said, these multiple applications, but one of them is the stock trader application. So if I right-click on that and I look at the designer there, you can see this is a much more richer application. It's a 4-tier application, and this 4-tier application has a data tier as well as 2 application tiers and a business logic or a web tier. And if we look at the data tier, we know that it's installed first because we have to install the database first before we install the other things. We have all the configuration for that SQL DAC, for the SQL instance inside that machine template. Then we install the business logic and the order processing tiers, and we use Server App V for each of those applications. Same underlying OS instance, but different applications deployed on it. And then lastly, we have the web tier. And again, we talked about scale in, scale out. We have the scale parameters already built into that. The last thing we have is the ability to set what we call a versioning for this application. That means that if I make a change to this application, I can up the version, save that, and any service I've deployed already it'll tell me that, hey, you need to deploy and update this service. So the service is already deployed. I need to update whatever it is that I've changed within here. And one of the things I can do is look, the last thing, and this is I think the most important and what differentiates how we view services, is that I can set up how these services talk to each other. And let me show you what I mean by that. So if I right-click on this service and I click deploy, because now I'm ready to deploy this application. You saw Joey do it today with project codename Concero. He can just log in there with the self-service portal, hit deploy. I can do it over here. And inside of this, I'll pick a cloud that I want to deploy it to, and we'll pick the production cloud, and hit OK. At this point, it's going to open up a deployment window where it's using intelligent placement to figure out which servers within our cloud that it wants to deploy this node to, all the different VMs that it makes up this service to. So you see right now it's thinking, where am I going to deploy each of these different individual servers? And as you see, I'm going to try and deploy 3 web servers, as well as one of each of the business tiers and the database tier. 2 things I want to show you here. First of all, if I want to make a change, like I want to change the name of this machine and these machines to follow a different naming standard than the default here, I can change it and call it like W1. And I can do this for all the different servers inside of here as I see fit. And the other thing is I can set parameters in how these machines talk to each other. So right here, I say, what's the root web machine name? So what's the default web machine name that I want people to connect to? And I'm going to call it w1.contoso.com. It's W101, right? And then the other thing is I can say, what are each of these different tiers? And when I put values in each of these tiers, or each of these variables here, when I deploy that application, I inject those variables into the application at deploy time. This means that if I deploy it in production, I put my production values here. When I deploy it in dev, I put my dev values here. And when I deploy a second instance in dev of that same service, it puts the other instance. So if I'm talking to different SQL servers on each of these, I'm talking to that SQL server that's corresponding to that service and not the one that I did when I created this application using Server App V.
So basically, the service template has standardized the application shape itself. It's standardized the procedure that we go through to provision each one of the components. And then we just use these parameters to do the last mile customization as we target one environment or another.
Exactly. And by doing this, I can simplify my deployment by only having to push in the variables that I need to change at deploy time. And I can easily now deploy those 4 instances of the service that I talked about earlier from using the same service template.
All right.
Thanks.
Thanks, Ken. Let's give him a hand. All right, well, we're kind of in the demo part of the show, and this is going to go quickly through a number of pretty cool pieces of technology. As we get into this, you should know that all of the technologies that we are seeing are in beta, and Virtual Machine Manager, you can get your hands on that at the link on the screen. Now, it's one thing to go and provision services and define them in all of their complexity, but the important piece is that we can manage to the SLAs that we've promised over the life cycle of those services. And our heritage here in System Center really goes back to Operations Manager, a tool that many of you are likely familiar with. And from an Operations Manager perspective, we made significant investment in the 2007 release to get to that service level view, that comprehensive view, not of different elements, but their relationships to one another so that you can have those diagram views of the running services. Now, since the 2007 timeframe, we've been providing the ability to manage applications as well as operating systems and those whole services through deep insight that you impart to the system in terms of management packs, whether it be for a .NET or a Java application. But the insider knowledge imparted to the machine gives you tremendous oversight of the SLA. We also added then watchers or points of presence that can give you an external perspective. A synthetic transaction, run synthetic transactions across that service so that you can simulate things like a login transaction or maybe a shopping cart transaction against a web application. So that's there, giving you external view into your applications and services. Then we spent some time thinking about how we could improve this, and we got a lot of feedback around one of the partners that existed in our ecosystem named AviCode. And AviCode was providing performance management at a transaction level for applications and working very closely with Operations Manager. So last year we decided to acquire AviCode. And in the System Center 2012 timeframe, we're going to take AviCode and deeply integrate it into Operations Manager, giving you transaction-level visibility for your complex applications that simulate real user experiences, not synthetic transactions, not insider knowledge imparted to the system, but without any instrumentation, transaction-level knowledge of complex services that give you the real experience of end users from the time they click on their mouse or they enter a keystroke all the way through the entire application, including its data components, et cetera, and pulling all of that information back to something that you can use to manage the SLA. Now, the important thing about AviCode is that it starts to broker a new type of conversation, one between development and operations. Instead of getting into finger pointing between dev and ops as to whose problem it is, AviCode will not only give us good insight as to what's failing in the environment, but give us the language with which to transact the resolution. So I want to bring up Sean Christensen to the stage, and Sean is going to walk us through some of the AviCode capabilities now in Operations Manager.
Absolutely. Oh, no. I had to do that. There we go.
Aha.
Now we'll switch over to here. There we go. So, as Ryan said, I'm going to show you how you can enhance your conversation between ops and dev using AviCode and using Operations Manager. And what I'm showing you here is actually a glimpse of Operations Manager 2012 and some of the new dashboarding capabilities. And what we have here is our stock trader application that Kenan showed earlier through the Operations Manager dashboard and giving us that rich end-to-end view. So we're not just looking at the infrastructure of the application, but also the application itself and how it's performing. And through this rich knowledge, we can get a sense of how this application is performing, what, where it is, where the performance challenges might be, because I got a little map over here showing me where stock traders deployed around the world. You can see I got a little red X, so we'll drill into that a little bit more. We drill down a little bit further here, we can see we've got a performance counter listed, showing us the response time of the server. And it's creeping up above 2 milliseconds. So, okay, let's go and actually take a look and see why that's happening. So I'm going to go ahead and open up my application client performance and see all that purple?
That's waiting.
That's waiting.
It should be waiting.
We got server response time. It's taking a little bit longer. Why is that happening? You ever have these conversations with the developers? Hey, server's running slow. It must be the code. What does the developer say?
What?
Yeah,
It must be
not
the
my
box.
code, it must be the box. You ever written bad code?
No.
Actually, have you ever written code?
I can guarantee I've never written bad code.
Okay.
Or good code, for that
Good
matter.
code for that matter. So now we can actually come to them and say, look, let's have a real conversation about what is happening. So we're going to go ahead and open up those alert details. Take a look at the response group view. Expand a few things. Click expand all. And, oh, response time. What do we got here? SQL exec processing. Drill down a little bit more. Hello, come on. And we have a stored procedure that's taking a long time. So using AviCode, we are able to drill in and see exactly what is happening inside my .NET application and take that information to the developer. Now, instead of screenshotting this, go up to our Actions menu and say, OK, do I want to copy that, send as, save it, export to email? Ship that off to the developer and say, use the old double comment. Look, actual code. Here's the problem. Go fix.
Beautiful.
Now, if you're like my manager, who's sitting right here in the front row, so I got to be nice, they like to see stuff. So what did we do? We went ahead and made that part of and allowed us to embed these dashboards in SharePoint. to give your management that view of overall application health end to end, which is what they want to see. And again, similar view to what I was just looking at. I got my performance information, I got my response times, and I got that full end-to-end view of the application using Operations Manager and the AviCode.
Awesome. Thanks a lot, Sean.
Thanks, Ryan.
Let's give Sean a hand. So what you see there are two major benefits or improvements to the Operations Manager experience. One is we simplified the creation of dashboarding, and we improved some of the dashboard controls that gave some of that richer look and feel that many of you have been asking for. If you go through any of the dashboard authoring experiences this week, you're going to find that the simplicity there will blow you away. It really is meant to make just simple 5-click authoring experiences for rich dashboards. The other piece that you saw was the transaction management integration from AviCode into the Operations Manager experiences. And then the last piece, which you didn't see there, was improvement of visibility over the entire running service. One of the things that we'll be bringing forward in Operations Manager 2012 is insight not just to the application, not just to the operating system and the compute and storage pieces, but also network monitoring. We've been working with EMC to bring smarts capabilities into Operations Manager. And out of the box, we will have network discovery as well as all of the device catalog from smarts, so that you have network management in the context of your running services. This is important as well as you think about problem resolution, because not only is it sometimes dev and ops finger pointing, but it can also be, hey, we have a node that has failed, when in fact there's a communication breakdown between that node and the switch. And so with the smarts IP now in the box of System Center 2012, you're going to have all of that insight for your applications. All right. Moving then to automation and control. I talked about how in our global data centers, not only is there a draconian process, but they run book everything. Very few kind of human interactions allowed along with the system. And one of the things that we've had in System Center for some time is deep automation within our tools or our own consoles, so that Operations Manager and Virtual Machine Manager can speak to one another very clearly and drive change or drive tasks at the system level between those consoles. But the feedback we got is, hey, it's not just a System Center world out there. There's a bunch of third-party consoles that are really important in the running of this infrastructure. What about my storage manager? What about my database environment? What about my network manager? What can you do to interoperate and connect System Center to all of those resources? The other thing was, how do I manage and create my own runbook or automation experiences? And how do I codify those and collect them in a library that I can manage so that I can start to build repeatable IP within my organization? Well, again, listening to the feedback, we went to our ecosystem and we found a partner named Opalis, who had been leading the industry in IT process automation for the last 13, 14 years. And we made the decision to acquire Opalis and bring them into the System Center portfolio. Now, what Opalis gave us is really two things. One is a hub-and-spoke interoperability model, where Opalis provides connectors for third-party consoles, third-party infrastructure, and brings them back into the System Center infrastructure so that we can automate tasks across anything you need, really. Your help desk vendor and operations manager, or configuration manager and a particular change process that you might have running in a non-Microsoft process manager. The other thing that Opalis offered us was a rich array or a rich library of common tasks that are already authored in runbooks out of the box and can be executed using the task engine in Opalis. Now, as we move on to System Center 2012, that's getting a whole new experience or a whole new integration into the System Center suite of products. and you're going to know Opalis going forward as Orchestrator. System Center Orchestrator is going to be the engine by which we provide a lot of the system-level automation, the task automation within your System Center-powered data center. Now, this investment, together with Service Manager, where we manage IT process and the overall approval authorities for complex change, really gives us a powerful 1-2 for managing those complex changes and requests that you might have. And so what I'd like to do is bring up Adam Hall to show us how Orchestrator, together with all of the other System Center assets, can help to drive some great benefit in the environment, including bypassing complex login screens like my other demoers have struggled with. Are you on E?
I'm an E. Yes. All right, thank you, Ryan. So you've seen a lot today about abstracting away from the complexity at the bottom and dealing with lots of different systems and moving up to an automated layer. And as we move from Opalis through to System Center Orchestrator, what we're going to see is that deep integration and being able to cut through all of the different silos that are involved in what are really quite simple tasks, but they cut across lots of different components of the data center. So what you're seeing here is the System Center Orchestrator pre-beta build. As Ryan said, we're moving into beta with all these products. The Orchestrator beta will be available in around about 3 or 4 weeks' time, so we're nearly there. And what we have in this environment is a number of runbooks that we have executing. And one that I'm going to show you today and put Orchestrator into flight mode is show you how we can move or do a simple task, which is moving a SQL database from one server to another. Now that sounds like a fairly simple process. It's just a matter of backing up the database and migrating it. But what that involves is lots of different technology groups, lots of different infrastructure, all being orchestrated in a very concerted way. And what often happens in this is you don't capture all the knowledge about who asked for that database to be moved, why is it being moved, and all the information about that. Now, why are you moving the database? It could be an incident, it could be a problem, depending on why you're doing it. Today, we're going to go through a scenario where you are moving it as the result of a need to change. So I'm going to go ahead and start this runbook. Now, typically, this would be something that is piped in automatically. For the purposes of demo, we're going to manually just type in what it is we want to do. So we're going to take that stock trader database. If I could type, would be helpful. Right. We're going to move it to DB02 from DB01. Actually, the other way around. DB0 destination server is 1, and the source server is 2. We'd get a nice failure if I did it the other way around.
We'll find out in a moment.
Yes, we're going to use the Orchestrator server to do this, and that is now kicked off. So we now have a new instance of this runbook executing in the background. We'll go and view the instances, and we see that we have the migration in flight. And if I view the details of that, if I've typed those around the right way, what we're going to see here is a graphical representation of the runbook executing, and you can see some nice little symbols, and we're going to see some green ticks coming across. Now, if we look at what this runbook is actually executing, the first thing we're doing is validating that the data that we've got is accurate. Are we trying to move a database that exists, and do the server names we typed in exist? Then we're going to capture an incident inside Service Manager. We want to know who asked for this change, why are we doing it, and all of that information about the request that's going on. If we jump across to Service Manager, if I do a refresh here, we'll see that we have a new incident has been raised. IR number is 116, okay? This is a dynamic number that's created. Remember that, 116. We're now ticking through, and if I minimize this down, oh, and we've got another timeout. Look at that. Live demo.
Quick, catch up to it.
We've got to be quick.
The thing is, Orchestrator continues to work in the background, and he's missing the opportunity to show you the database.
So what's happening in the background with the DPM server that I don't seem to be able to log into? There we go.
Yay.
Hey. So DPM is doing the synchronization. If you were quick, you would have just seen it there. And we've now taken a snapshot of that database. You want to back up in case anything goes wrong to get back. The next thing we're going to do is we're going to export that database out to a network share. Okay, this is automatically dumping out. We've taken it back up, we're going to export it. Belt and braces. If you're moving something, always have lots of copies. We've now created a dynamic PowerShell script. We've typed into the PowerShell script name that IR116 number. We created a dynamic PowerShell script. We piped in the parameters that were required to do the migration. That is now executing, and if I do a few refreshes up here, we'll see that the stock trader database is now restoring. You can see that happening in real time. Do a refresh, a couple of refreshes, that'll take a sec. That is now being restored. If we jump back over, we'll see that we've now progressed through there, and we're now going to go back to Service Manager and close out that incident, and you'll see if I do a refresh that it will move to a resolved state. Now, what we did there is pull together Virtual Machine Manager, Service Manager, Data Protection Manager, and PowerShell, all into what was quite a simple process of just moving a database. And if you think about what Ryan was talking about, the extreme standardization and abstracting all of that and automating standard tasks and moving to a very hard position on change control, you're going to do lots of changes, but you just want to capture the fact that it happened. And when a person is involved, it wants to be a very large change. So we captured all that information and we moved the database. So
that's fantastic. Nice job, Adam. That's a really tough demo because once you kick it off, there's no going back. And so you better be hopping around from window to window. So I thought you did a nice job of getting past the hiccup there. So I wanted to bring us back to maybe where we started this morning. And I wanted to revisit Concero. Because Concero isn't really targeted at the conversation that we've had today, although it's the outcome of it. There's this equilibrium that we want to find between empowerment and control. And Concero was built with the notion that there's all these business unit IT folks who want self-service empowerment for the applications that they run and they deploy. They want to party on their cloud without a whole lot of interference or break. I'm getting chuckles. It's true, right? Now, the other piece, though, is from an administration standpoint, we want to ensure that the data center has as much control as possible. I don't like to give a lot of empowerment if I can't be sure that it's not going to muck up either the neighbors or they're not going to end up deploying services that then we have to support because of their misconfigurations or any other issues that they might run into. So what I thought I'd do is I'd bring us back to Concero and hop into basically the demo that Joey Snow showed this morning. And let's just remind ourselves of how these experiences of self-service for this application owner or this business unit IT person relate to the control and simplicity that we talked to along the way here today. And the first interface, Joey was interfacing with this IT portal. This is just a web portal. If I do my F11, I'm just in a browser here. And this is where he requested a cloud. And if you think about these sort of interfaces, they're capturing really simple information from Joey or from that business unit administrator. The person really doesn't know all of the complexity that they're really asking for. They don't know what they're really asking IT to do. They're just saying, hey, I want something like a production cloud. Since it's production, I'm going to make it a platinum. It sounds like it ought to be really big, so I'll get the platinum tier. And maybe it's because I want to deploy some new service out of test. And we can capture some of the things like what data center is going to be close to us, et cetera, and some information as to where I work so that we can do some chargeback down the road. But that's a pretty simple conversation we're having with this person. And behind the scenes, we need to capture all of that simple intent and shred it into very fine-grained tasks that are both machine-based and process-oriented. We need to go and get the approvals for the changes. We need to go and understand all of the different steps that what we need to take in the infrastructure. How we do this is with a combination of Service Manager and Orchestrator behind the scenes in Joey's demo. In Service Manager, what we've done here is we're really using this portal to publish the service catalog. These are standardized services that we've modeled out in Service Manager. We've said, hey, there's this thing called basically a complex change request that says create a cloud. And it involves all of these different steps. And where we can't automate through native calls through System Center, we use Orchestrator to reach out to third-party systems and orchestrate all of those tasks, all governed by the System Center change management process. So that's how the first step worked. Then we hop over to Concero. And in Concero, we were able to view, if you remember, the clouds that Joey had provisioned for him. Well, this goes back to that earlier part I was talking about, Virtual Machine Manager, assembling this slab of infrastructure resource and then carving it up into individual clouds. Well, down here, if I look at these VMM clouds, these are just the different logical data center instances that have been provided for individual users. And because we've put our role-based access control into this infrastructure, we can determine who is allowed access to these clouds or not. So that's basically an experience or visibility into a virtual machine manager capability there. The other thing that we talked about was Joey ought to be able to deploy a service. And so when Joey came in here, he was asked, he said, I want to deploy a service, and I want to do it on this particular cloud instance that I've been granted access to. And on that cloud instance, there's already a set of templates for me. There are a set of simple machine templates, but there's also a set of complex service templates that he was able to pick from. This service template is like that one Kenan came up and showed us how to author. Joey can't just create any old service template and deploy it on his cloud. He gets to pick from a list of approved services that he's allowed to interact with. And if you remember, the service template has a whole bunch of parameters in there or guardrails that make sure Joey's not going to run amok. It can scale in and out, but it can only scale up to, I think, what did you say, Kenan, 5 or 6 virtual machines at the maximum, and had to be a minimum deployment of 3. So we've taken away some of the knowledge that Joey needs to have in order to be successful and still give him the veneer of empowerment, but we maintained all the control. So that's kind of a bringing it together of all of the different piece parts you saw. How Joey acting as a self-service user in the morning was really only enabled by the good work that we did here across the orchestrator, the service manager, the DPM, the virtual machine manager, and the operations manager experiences in the data center. So we'll hop back to slides and we'll close it out. The things that I'll leave you with, and hopefully we've shown you a little bit of today, is that the private cloud is something that is real. It is something that gives us an opportunity to revisit the concepts we've been after and the goals we've been after and make them tangible, make them real for our organizations. But the private cloud, as we see it, goes far beyond automating the provisioning of machines. The private cloud has to deliver on your business goals. And your business goals are tied to your applications and the output that ultimately IT is providing to the organization. You see, we spent most of our time focusing on application creation, application maintenance, and application orchestration today. Because table stakes is getting the logical footprint of infrastructure built. We have to be able to do that. But then we have to be able to look inside that cloud and understand what are the services that you want to deploy, and how can we give you the most successful model for deploying and servicing them throughout their life cycle. The second piece we talked to today, we didn't show it as much, and you'll see it throughout the tracks this week, is Microsoft's taken a position and made a decision to be cross-platform from the metal up. That means our hypervisor needs to support a broad number of guest instances. But even our cloud configurations, our virtual machine manager needs to embrace multiple hypervisors, like Zen Server and like ESX. And we need to do this in a way that you can have as much cloud in your environment as you require, whether that is reaching out and embracing public cloud resources in conjunction with your data center assets, or bringing those cloud concepts into your data center and transforming the way you do day-to-day operations in a private cloud environment. And then the last piece is we talked about some of the benchmarking stuff is we're going to do this for all of your business applications, and we're going to be absolutely best at delivering a cloud infrastructure to run your Microsoft applications. That's SharePoint, that's Exchange, that's your web applications, that's your SQL servers, and frankly, all of your .NET applications are going to be first class on Microsoft clouds. So I won't go back and demo. I will say that from a roadmap perspective, we are either in beta or about to be in beta for the technologies here. You see the first half, calendar year 11. Those that are in beta now are colored in yellow. We're about to go beta for Orchestrator in just the next couple of weeks. And then it's going to be a large cycle of RTMs here in the second half of this calendar year, delivering all of the System Center 2012 capabilities in RTM fashion so that you can start to build easy to build, simple to use private clouds, so you can standardize the interactions with your applications and manage your SLAs for the organization. So please kick the tires of the beta, give us feedback, and let's look forward to building clouds with 2012 on the second half of the year. Thanks for your time. Please enjoy the week, and hope you have a great week of learning.